Big data has largely become an invaluable asset to organizations across a multitude of industries and niche markets. With the exciting growth our organization has seen within the last 5 years, me and the IT management team collaborated on an enterprise strategy prioritizing the modernization and fortification of our business. To build on those foundations, we will chart a path for our organization to thrive during these unprecedented times, evolve our data operations and IT resources, and cultivate growth. Hi, my name is Emmanuel Cortez. I'm the Chief Data Officer of the Setup Warehouse, where we specialize in selling products for offices, also includes electronics and furniture. And I'm excited to announce that I'm in partnership with our CEO, and we're pleased to announce the EDGE initiative. Now, EDGE stands for Enterprise Data for Growth and Effectiveness. Simply put, our organization is experiencing growth so large that it can no longer sustain its operations in its current state. And it's critical that we leverage advanced tools for big data to make well-informed decisions and harness the streams of data at the company. So we're going to transition into part one. And again, for this big data deployment initiative, we're calling it EDGE. So for a high-level overview of the purpose of EDGE, we really just want to strategically leverage big data technologies to extract value and make it actionable. And then, of course, like I mentioned, organizational growth right now is outpacing current operations in place. And then we want to scale our data operations. Now let's have a look at our firm size, sector, and competitive landscape. The Setup Warehouse, since 2018, has hired over 1,200 additional employees to service different departments across the organization. We will continue to invest in our employees and bring on additional talent as our evolving needs continue to take shape. Based on industry research, the office supply and goods market is in a tumultuous state, shifting focus in areas such as big data technologies, artificial intelligence, and e-commerce. Large problem areas that we are seeing involve increased digitization with remote work and learning spaces. While retailer challenges have persisted since the advent of the COVID-19 pandemic, big competitors such as OfficeMax and Staples are proving their resiliency. Setup Warehouse's response is no different. However, we must understand that the sector is estimated to decline 12.9% according to an IBIS World Industry Research Report. And this is a result of the poor economic climate and supply chain disruptions for our sector. Some of our competitors are well equipped with on-premise infrastructure, some are fully invested in cloud infrastructure, and some have a combination of physical and cloud platforms. As a new player in the office, supply, and goods market, the Setup Warehouse has the oversight and knowledge of the mistakes and hurdles our competitors have dealt with. None of this would be possible without the resources we have and are evaluating right now. Now let's go ahead and talk about opportunities and risks. Migrating big data from physical servers to the cloud for a company will vastly improve our processes and data management. Additionally, we expect improved efficiency in operationalizing queries and data models. And as our organization continues to grow, along with the volumes of data we are generating from a variety of sources, we are confident that the Google Cloud Platform will help the organization push the boundaries of how we can obtain value from data. So an opportunity we can look forward to is increased efficiency as, again, we have minimal barriers to operationalizing our data models and queries. And of course, we have advanced capabilities at play here with this new Google Cloud Platform that we're evaluating. and we will be able to deploy analytics, machine learning algorithms, and reap the benefits of real-time processing of data. Now, with a large investment in managing data in the cloud in-house, this eliminates potential savings if we were to fully outsource these tools and functions to an IT managed services company. This is what kicks off some of the risks involved. There are very many, but these are just the ones that are worthy of note. Again, an investment and opportunity cost of foregoing assistance from IT managed services and just being fully self-reliant and trusting our internal resources to carry out what they need to be able to manage our cloud environments. And that brings me to my next risk here in this table, cloud usage. Understanding the intricacies, platform cost structure, and alert systems will be really important as well. And it's a risk that is worth noting. We must have full confidence that who we hire to manage our cloud environment will fully understand all these components. Certainly not the last, but an important risk worth noting is disaster recovery. The setup warehouse is in its final few days of previewing the Google Cloud platform. We acknowledge that if we proceed with investing in the platform and initiate migrations, there is risk of cybersecurity threats and data loss. We have full confidence that we will securely migrate our data with the advances and efficiencies these processes have developed over the years. Now we're going to go ahead and transition to part 2 of this presentation, and we're going to focus on data pre-processing. Now you may be asking, pre-processing, what does that mean exactly? Well, pre-processing data simply means cleaning and shaping the data so that it can be used for analysis. In the data analytics lifecycle, data pre-processing, or probably better known as data preparation, is a vital step that requires arguably the most effort and attention to detail, as it is the wellspring for all the analysis we perform across the organization. Data pre-processing is the phase in which we clean and shape the data so that it is in a usable format to perform even the most rudimentary analysis to the most advanced algorithmic experiments. In this section, we will demonstrate how we can use different tools for pre-processing the data. So as a first step, we decided to use RStudio as it is an open source tool for building statistical models, creating advanced graphics, and even pre-processing the data. For this case, we are interested in cleaning the data so that it can be used for analysis by replacing commas with hyphens. Our attribute of interest here is the product name. We apply this step within pre-processing so that our dataset is query-friendly, and as we seek to store this information in a file management system, which we will discuss later. First, we imported the CSV file into RStudio, and then we used a couple of packages. We used the reader package, which is used for importing the sales dataset, and then we used a package called janitor, which specifically helped us remove the spaces between the attribute names. So for example, product name now has product underscore name. Again, we are taking more measures into ensuring that our data is in the proper format for data retrieval via SQL, which we'll get into later. And then again, we used more functions within RStudio to evaluate the structure of our data via the str function. And the structure function, it shows us how many attributes we have, how many records we have in our data set, what are the data types of each of the attributes, etc. And then finally, we used a function called gsub to replace the commas that were within the product name the product name records, took those commas out and replaced them with hyphens. Next on our list is we used another open source tool called OpenRefine. OpenRefine is a tool for pre-processing messy data via a web browser. And when I say it's open source, that means it's open to the public to use for their own use case. We're interested in cleaning the data in the postal code attribute. There are values within the column that have less than 5 digits within these postal codes, which renders an incomplete record. To accommodate for these challenges, we created a duplicate column with the same postal code values, except we utilize the general refined expression language via a script expression that will label or flag values with incomplete postal codes. So for this duplicate column, we created a zip code column to identify any code that had less than 5 digits. And then if it met that criteria, it would impute a value of 5 nines. And when we looked at the data, it had about 449 observations with this value. And once we created this particular function using the GREL language, we got our output in a separate column and now have it as reference. We also took a look at the state attribute. And after evaluating the data within the state attribute, it did not have any errors. And we'll go ahead and move on to the next portion. Before we go any deeper, I do want to help our audience have a high-level understanding of what each of these tools are. And as the setup warehouse continues to grow as an organization, we want our data governance tools to grow with it. That is why we are proposing an investment in the Apache Hadoop ecosystem along with the Google Cloud Platform. To guide the conversation surrounding all of these tools, here is how Apache Hadoop and the Google Cloud Platform are different. And then we have a third one that I will discuss here in a second. Apache Hadoop is simply a Java-based framework used for handling data in the cloud or on-premise. And then Google Cloud Platform is a cloud computing service that holds applications such as Apache Hadoop in a distributed environment. Also with Google Cloud, we use a tool called Dataproc, which is considered as the managed Hadoop for the cloud. It's a service specifically for running Apache Hadoop clusters in an efficient way. We'll go ahead and preview how these systems function together with our sales data. And with those in mind, we also have 2 options to showcase in processing queries from our sales data set: Hive, MapReduce, and then Spark. And of course, before we go into our outputs and how we generated outputs from the sales data set, we also need to preview Hive, MapReduce, and Spark. So within the Apache Hadoop ecosystem, there are a series of core subsystems. We will review the performance of Hive, MapReduce, and Spark later on in the presentation. But to provide further context, Hive is a system built on top of Apache Hadoop and functions as a data warehouse tool. Hive relies on MapReduce to be able to execute queries in batches. Spark, however, can run queries on its own and can support real-time querying. Hive and Spark can essentially achieve the same results with storing and retrieving data, but we will later see how both differ in performance and speed. And again, to kind of emphasize the differences between these systems, Hive and MapReduce, they work together, but specifically for MapReduce, it is a programming model that accesses big data in the Hadoop distributed file system, which we will also review here shortly. The Hadoop distributed file system is also known as HDFS. So now we're going to transition to part 3 of our presentation. We're going to talk about the Apache Hadoop ecosystem with Hive. We're going to run queries from our sales data set via Hive and MapReduce. But first, before we continue, I do want to provide some background on more components that got us to creating our queries. So we have the cloud storage bucket and HDFS. Google storage buckets are for storing data sets, which is where we imported our sales data set. So if you recall, we pre-processed the sales data set in RStudio for product name, and then we pre-processed the sales data set in OpenRefine for the state attribute and the postal code attribute. And then the most up-to-date current sales data set, we put that into a Google storage bucket. And in particular, for this bucket, we called it Big Data Strategy. Now the key here is that we use the Google Cloud Platform to store data, but also if we want other Apache applications to have access to this data set, we have to transfer the sales data set from the bucket to the Hadoop distributed file system, which, to emphasize more, is the primary data storage system that is used in the applications within the Hadoop ecosystem. And where we're performing all of these queries, we're doing it in a cluster node. And if you don't know what a node is, it's a single virtual computer used for processing and storing data. And we use a master node to help us transfer the sales data set within local storage to HDFS so that we can interact with the data via Hive and Spark. And before we can actually interact with this data with Hive and Spark, we have to establish what we call a schema. In other words, we need to create a table and we need to make sure that the data that we are putting in to Apache Hadoop is going to be correctly formatted. And we have to make sure that all the attributes within the data set have the correct data types, whether they're strings, which can be known as text, integers, which are numbers that are not decimals, or doubles. Doubles are numbers that have decimals in them. So as you can see here, we have an example of the exact command that I used. And here we essentially create an external table if one does not exist, and we give it the name sales table. And then we specify the format of this data set, and then we make sure that we specify that each of the attributes are separated by commas, and then we give the location of where this data set was kept. So like I mentioned before, we had to transfer this data set from the bucket to HDFS. And so as you can see on the bottom, the location where it has user and my username and then data, that is where the data set was transferred from. So it is now technically in the HDFS system. So now we're going to go ahead and talk about our queries here, and we're going to talk about the performance of these queries in Hive. So after creating our table and giving each attribute their proper data types, we queried the setup warehouse's top 5 US markets with the most customers. In our first line, we use a select statement, count the number of customer IDs, and label that as its own attribute, customer count. And we also specify what table we are receiving data from using the from statement, as you can see where it says from sales table. Next, we use a group by statement for state to show the top 5 markets. And then we use an order by with a DESE, standing for descending statement, for customer count, so that we can see the highest to lowest amount of customers in each state. Lastly, we conclude the query with limit 5, and then we use a semicolon, because in order to execute the query, we need to conclude with a semicolon. And we limit 5 because we're only interested in the top 5. I'll go ahead and show us our results. But before I do that, I just want to also call out that from this slide, you can see the B command line that is used to start up Hive. It activates the JDBC driver and just all the components within that. And here we have the result of our Hive customer query. As you can see here, our output gives us a nice tidy looking table where it shows the top 5 markets. We have California as the top one, New York, Texas, Pennsylvania, and Washington. And as you can see on the bottom, you see a figure for how many seconds it took to process this. We'll go into more detail about this since we are interested in comparing the performance of Hive and Spark, but we'll get to that later. For our second query of interest, we wanted to find the top 10 zip codes with the most sales. So in the beginning, we pre-process the data so that we can query from the data set in a distributed environment. So for this query, again, we find the top 10 zip codes with the most sales. In the SQL statement, we call out the zip code and sales attributes, but we also take the sum of sales and call this new attribute sales amount. Then we use a group by statement for these results, and we use it for zip code. And then we also use an order by statement in descending order so that we are seeing the top 10 where the highest amount of sales is ranked number 1, and then the 10th highest is on the bottom. So I'll go ahead and show you our results for this particular query for postal code, or excuse me, for zip code. Now, there's something interesting about this output. For our sales query in Hive, there's something that is very strange. Can you tell what it is? Well, in this first result in the table, we have those values that we retrieved when we wanted to flag the zip codes that had less than 5 digits. And now we're seeing it as the zip code with the most sales. This could be problematic. In fact, it's probably best that we do not use these results in reporting. The reason why we're seeing these 5 nines at the top of this table is because we are using the duplicated column that we created in Open Refine. So it's probably best that we query the original postal code attribute rather than the zip code attribute that I created. Much better. So now we have our true postal codes showing our top sales. And as you can see in the first 3, these are located in the New York area, which is no surprise to us, as New York is one of the top 5 markets for customers. Now we're going to transition to part 4, where we'll talk about the Apache Hadoop ecosystem and with Spark. We're going to go ahead and run the same queries that we did in Hive, but we're going to also notice some differences within the interface and within the performance. Again, we find the top 5 states with the most customers in Spark. Now we have a different command line to initiate Spark. We use simply spark-sql. And again, just as reference, we use the same customer query to get our results. And here's a look at my Spark customer query. And it's not as nice of an interface, I must say, compared to Hive, but there is something that is worthy of your attention. If you look at the very bottom, it says time taken, and it says 1.923 seconds. Now, if you remember, previously we had this same query retrieve results in just under 18 seconds. Now, what does this mean? Well, we'll go ahead and explain these differences later on, but that is a huge difference. Now we have our top 10 zip codes with the most sales in Spark. Again, we use our same queries as before. We use the postal code attribute instead of the zip code attribute created in OpenRefine. Just so, again, we're not retrieving those 99999 results. And so now let's go ahead and see our output for the sales query in Spark. So probably a little bit harder to read, but we get the same results as we did in Hive. And look again at the time taken for this output at the very bottom. We see that for this query in Spark, it only took just over 4 seconds to fetch all of this data. I think we're seeing a trend here. And to transition into the last portion of our presentation, I'm going to go ahead and compare the performance and give a reason to the rhyme as to why we are seeing such huge gaps in the performance of Hive queries and Spark queries. For this next portion, we're going to answer 2 questions. How fast can these queries process the data? And then if there are any gaps, again, what could be the potential causes? So now we're going to just have a high-level overview of the differences here. In Hive MapReduce, the customer query performed at 17.97 seconds, whereas for the Spark query, the customer query performed at 1.92 seconds. That's an 89% improvement. And then we look at the sales query. Similar performance as the customer one in Hive, the sales query performed at 17.78 seconds. And as for the sales query in Spark, it performed at 4.13 seconds. Now, Hive functions in a batching process when it handles query. The key for this, MapReduce. MapReduce is what works in conjunction with Hive to help execute jobs when it's processing data. It cannot process data in real time. So if I was an organization evaluating a particular function, maybe a good use case for this would be to just have a dedicated data warehouse tool, and maybe I just want to query historical data, then Hive would be your best option here. And with that said, regardless of performance, Hive still offers a lot of value for organizations. And just to reiterate, Spark and the customer query, it performed 89% faster than the Hive query. And then the Spark sales query performed 76% faster than the Hive query. Spark will consistently outperform Hive in processing queries. So with that said, with your buy-in and with your guidance, we would love to invest in the Google Cloud Platform, and we'd also like to incorporate Apache Hadoop within our data operations. Our sector is at a crossroads with a single question in mind: repeat or evolve? The setup warehouse unquestionably should always choose the latter. The analytics and BI management staff and I will work hard to seamlessly transition our organization to using big data technology. The Apache Hadoop ecosystem, when combined with a cloud environment such as the Google Cloud Platform, will position our company to be an emerging leader in the office supply and goods sector. I just want to say thank you for attending my presentation. If you'd like to reach out to me, here's my email address. And of course, here's a link to our website. Have a great day.